Hello everyone, welcome to this channel Coding for Dummies. In this particular tutorial, we are going to learn about C programming language. Okay, so here I assume that you have a very little knowledge or have no coding experience at all. So keeping that in mind, I will build this tutorial videos so that you can get at least some basic knowledge to get up and start running, or actually should say start coding in C programming language. And once you get to understand the basics of programming language or C programming language, you would easily pick up any other language that you would want, like C++ or Java, anything. Okay, so let's get started. So what is a programming language? You have heard, okay, let's learn about C programming language, but what actually a programming language is? So before understanding what a programming language is, we should understand, okay, how computers do the instruction that we provide them. Okay, so for that, let's understand there is a computer. So we all know that computers understand only these binary digits, zeros or ones. Okay, but if we see humans are not that good at understanding this binary language, okay, like zeros and ones. And on top of that, computers are very good at repeating their tasks. For example, here we have provided the computer with a set of blocks with unequal heights and random order. So we have given this computer an instruction, okay, sort these blocks according to their heights in ascending order. So what it will do is it will take this as input, produce an output which is these blocks only, but they are sorted according to their increasing heights. Okay, so as I have said, computers are very good at repeating tasks. So what happens is, whenever you give some input to the computer, it will provide the same output for the same particular input. For example, if you get this particular input to the computer for 100 times, it will produce the same result for all the 100 times. It is not going to be a such that if we produce this particular input for the first time, it will give some other output, and for second time if it gives the same input, it will give some other output. So this capability of the computer to repeat the tasks and generate a particular output for a given input, this is the main or what you can say, this is the power of computer. It is very good at repeating tasks. So we use this power of the computer to write our logic or to solve our problems. For example, if we write a particular program to find the maximum between a set of numbers provided, so that logic that we have written will always output a same number for a given amount of for a given input. Okay, so this thing so here we can see the repeatability, how it is repeating the same logic and giving us the output. So if suppose if you are given four numbers from 1 to 5 and you have written the instructions to find out the maximum of those, so it will produce 5. The next time you give the input from 5 to 10, so it will output 10. So whatever the logic that you have written inside the code, so that set of instruction will be executed and will produce a result. It's not like that first time if you have given the numbers from 1 to 5, it will output 5 as the maximum value, and the next time if you input 5 to 10, it will again output 5 or 6 as no, it will not. It will again produce 10 as the maximum value. So this is what I want to say, that computers are very good at repeating tasks. Okay, now we'll see what are these programming languages. So basically programming languages are divided into two parts, low level and high level. So what does this low level and high level mean? So at a very superficial level, low level means that the code or the language that is close to the machine language or machine code is called as low level language, whereas the others which are more towards the human readable form is called as high level language. Then the examples of this programming language is C and assembly language. Okay, and here this is C++ and Java. Then again, why to learn C? So if you can see, or C is the base for many other programming languages like C++ and Java. And the basic concepts such as what are data types like integer or character, all these operators like plus, minus, divide, modulus, and all these operators, control statement means like how the flow should be controlled. Okay, we'll discuss all of this in the upcoming videos, and many more of these things are very similar to other languages. So if you learn C, it will be very easy for you to like pick up any other language like C++, Java, or any other language, because these are basic concepts and these remain same in all other programming languages. Then we have C can be used widely in various applications. It is a simple language and provides fast execution. See, since I have said that C is a machine level code or low level code, so what happens is it provides faster execution, or it provides more what you can say uh, grip over how we want to execute our process. Okay, so it provides a better control and produce faster outputs. Then C language is widely used in embedded system and also used for developed system applications. So since C is a machine level language or low level language, or is very close to the machine code, is it basically or mostly used in writing the codes for these operating systems, writing the for this embedded system like microcontrollers, processor, and all these things. Okay, so here is it. Highly portable language, which means program written in C language can be run on other machines. Okay, so this is the characteristics why you should learn C. So uh, learning C will give you a very basic or the granular uh, knowledge about, okay, how these things are working and how these things actually work. Because if you go in any other languages or some other languages which are a high level language, there what will like you will be provided with a set of functions that will give the output that you want, but what is actually going on behind the curtains, that you will understand with C. Okay, so what are the characteristics of C? Here, it is a low-level programming language close to machine language. That is, it provides little or no abstraction from computers, instructions, and set architecture. So we'll see that since C is a programming language, it provides a very fine control over what we want to do through our program. Okay, just to give you an example, with C there comes a concept of pointers, which is not there in Java. So Java, since it is a high level language and C is a low level language, C provides a better control or better control of how we can access this memory with this pointers concept. Okay, don't be scared with these pointers and all these things. We'll discuss this in full depth. You will get a much clarity about pointers in the upcoming videos. Just to give you an overview, what are the characteristics, I have just like raised the point. Then it is a procedure language. Procedure language basically means that like the program that we have written contains a set of instructions or set of statements. So what this means is this particular set of statements, there are 10 statements. This will be executed one by one. Like the first line will be executed, then the second line, then the third line, then the fourth line. It's not like that it's randomly executing the code. It's not like it first executed the code on line number 10, then 1, then 2, then 6. It's not like that. It is a procedural language, so the codes that will be executed or the instructions that will be executed line by line. Okay, 1, 2, 3, 4, 5, like that. Then comes, it is a structural programming language. So just keep it in mind, structural programming language means many of the functionalities in C or many of the codes in C are written inside functions or a set of blocks. So whenever you want something, you can just call that function and get your output. Okay, so this is what I mean. Okay, then it is a highly portable language, as we have discussed in the previous slide, and the closely associated with the Unix system. Just I have mentioned in the previous slide itself, this Unix system, the operating system, Unix operating system, most of the programs that runs of this Unix system and the Unix system itself is written in C. Okay, so what you can see, this is a source code, and when we write this source code, here comes the compiler. The compiler converts this source code to this compiled code, and then there comes the linker that will convert this compiled code to executable code. and for all of these we will use code blocks. Okay, so what I want to do is, what I want to through this PT, what I want to say is how the code that we write gets converted to actually the binary code. Because since humans don't understand this binary language and we need to write code, and computer understand only binary language, so there must be something that bridges the gaps between this binary language and the human readable language. So here comes the programming language. So we are write our source code, or we write our code in the source code file which has this .c extension. Okay, see .c extension, then it is picked up by the compiler here and is converted to a compiled code with .obj or .o extension. Then this linker will come and will convert this object file to an executable file. Okay, so in this way the code that we have written here gets converted to the machine code, so that machine could understand it here. Now we can see here what does this all compiler and linker do. That I'll just give you an overview. So suppose this is your source code. Okay, this is a file, there you have written your source code here, 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 here you have written, and your source code has some part which says that it depends on, like it needs some functionality from other source code. Okay, here. So for running your source code you need this source code as well. Okay, the help of this source code as well. So what will happen is this compiler will convert this source code into an object code or object file here, like abc.object, and it will contain, this particular file will contain that part which has the link to the external file here, this one. So this part of the code below has been converted the object code, object file, and this particular link to the other file is taken care of by this linker. What this linker does is that whatever file that is referenced here will be picked up by the compiler, and that will be merged with this particular file, and then a resultant exe file will be created, which will be a self standalone file which don't need any other file for its execution. Understood? So I'll just go through it again. I'll quickly go through it again. So you have a source code that have a reference to another source code. What will happen is when the compiled code or the compiler will convert this into a compiled code, it will still have reference to that particular source file. Okay, so now what the linker will do is it will check, okay, what file it needs, it will get that file, again put it here together. Okay, so what happened is here one file, then two file. When the compiler executes, these two files got converted to obj objects, one object, second object file. So but these are two different files. The linker came, put these two together and created a single executable file which can then run by itself. Okay, so this is what the linker does. So to execute all these three processes together, we will use an IDE or integrated development environment. What it means is, which is the code blocks. So what we'll do is, using these code blocks, we'll write our source code, and what this code blocks will do is it will automatically compile it, link all the files, generate the executable file, as well as run it to give us the output. Okay, so this was the very basics about what the programming language does and how we are going to proceed in the upcoming videos. So I hope you have liked this video. If you have liked this video, please like it, share it, and subscribe to the channel Coding for Dummies. Thank you.